Okay, everyone. Let's get started. Hi, everybody. Welcome today for our two student talks, Yana and Maxim. Yana, you're up first. So if you want to go ahead and share your screen and get started, that'd be great.
Just a minute. Hello, everyone. I hope that you can hear me well. Just a moment. I'm sharing the screen. Um, can you see my screen now?
Yes.
Great. Yeah. Hi, everyone. My name is Yana. Um, today I'm presenting um, today I'm presenting WLCG OCG network monitoring project. I had a pleasure of working with Petya Vasilyeva, Sean McKee, and Marian Babik for last 6 months. To be honest, even a bit more, as I've been a Irish summer fellow before. I really find this topic to be very interesting and with lots of insights and underexplored fields that are worth being working at. And before we are jumping into other project directly, I'm not sure what is your background, whether you are working with WLCG closely on an everyday basis or not. So to provide a kind of a small background, WLCG or computing grid was initially created to deal with a huge amount of data. We are talking about 200 petabytes per year. And it provides scientists with ability to exchange this information with the data from experiments from Large Hadron Collider to analyze it, to process. And as I've already told, this computing grid is dealing with a huge amount of data, and it will experience even more data after high luminosity LHC is starting to operate. And of course, as every huge system, we can experience some issues here, and we want to address them as soon as possible and to provide scientists with a as smooth experience of using it as possible. Um, but lots of things, like we lack lots of insight in this, and that is actually what is driving our team to develop and to research this topic. First of all, let's start with the issues we can face in WLCG network performance. Um, Scientists are like users of of computing grid, and while they are working with all the data, they can experience, for example, delays in their workflow, or they can get incomplete data. And of course, then you have, for example, time sensitive workflow, or in general, you just want to be as efficient as you can. That is the last thing you'd like to experience. Um, this can happen to many, due to many factors that we are trying to observe and to catch. For example, some sites they are providing storage for more data than others, and they are of a higher demands. But if they are simultaneously with that, they have like limited capacities, then of course they will slow down transfer and processing. And some sites, for example, can experience disconnections on their links, and as a result, the user will either experience again the delay or loss of packages and similar things can happen all the time. And we are trying to search for it and to highlight and to address these issues. Um, so, as I already mentioned, of course, we have lots of insights. We still would like to to explore. But what we already have is a great data to work with and to explore. And right now I'm talking about Personnel Measurement Toolkit, which is widely deployed among WLCG, and which provides us with a data about latency, throughput, and packet loss. And this rich data set allows us to monitor the health of individual network links or to identify bottlenecks, and to search for these roots of problems to be at least one step closer to it. And for example, latency and packet loss measurements, they can highlight congested or faulty links, while trace routes help us pinpoint their packets are delayed or for example, dropped along the path. And now then you know a little bit about the data we are working with. I would like to introduce you kind of a project, a web app the team had been working in long before I even joined this team. So the idea is that if we have this data, this useful data, and if we want to address the issues more efficiently, we are storing all the data. So we have access to real-time and historical data as well in Elasticsearch. The core of the app is alarm generator. Alarms are Python scripts we are developing if we find pattern that is which is repeated, and we want to keep tracking it, and we consider it to be important for example, site admins or other people who are taking care of WLCG performance to be aware of them. So this alarm generator is also providing us with the data we are storing in Elasticsearch, and the user can go to the web app called Alarms and Alerts, subscribe to alarms and alerts that we developed, which may be of potential interest to them. And after that, he or she is getting the email with a small message about our alarm, and also with the link, which provides the user with visualization of what is happening, why he or she is getting this alarm. And based on this, they can make a decision if they can do something about the issue they are facing. So now then in general, I described you the flow. Let's quickly go through it. So that's how alarms and alerts page look like. And this is, for example, my subscriptions. The idea is I'm getting lots of alarms as for now because I'm subscribed to several of the alarms. And here we have a tags. You can choose the sites which are of your interest and only get the alarms about them. But I'm interested in how the network is working in general, so I'm getting about all the sites. This is how the email looks like when you are getting notification about the alarms. You're getting it regularly. It also depends how often we are running the alarm, because different alarms require different frequency. And here, for example, I highlighted one of the alarms because you are getting the list of them. On the next slide, I'm showing the tag I was talking about. So if, for example, I have chosen only mid-LHC01 side, the Michigan side, I would get only alarms about this side. And here we also are showing the category or subcategory of the alarm as we are interpreting it, and as well as alarm name and the link to the visualization. So if we are clicking on this link, we are going to PS dash, and we can see the visualization of the given alarm. On the previous slide, I just randomly chose one alarm among all the alarms I'm getting, and that was alarm about a firewall issue. And we can see the emptied visualization from Elasticsearch uh, about firewall issue we experienced on a given site, uh, and a short message with a description with a given alarm. Um, and after that, as I noticed, like on the previous slide, I've noted that I'm getting not only one alarm about a given tag, about a Michigan site, but also one more, and I had a bigger list. So I've seen that there were lots of alarms coming from this site. I went to site report. That is actually the feature I had been working on this last several months. We wanted to gather all the alarms about a certain site on one, like in one place, to have a bigger picture of what is happening to the site and whether the events are interconnected and whether we can do something about them. So, for example, I could have seen that I'm getting lots of complete packet loss alarms, and I wanted to know what was the reason for that. Luckily, here the reason was quite simple. There was a firewall issue, so there's something about site configuration that is not allowing for packet to be delivered to that site. But the reason can be, like, the events can be different, and the reasons for them also can be different. Of course, I prepared some screenshots of the sites and the cases, which are easy for me, to explain you and not to take too much time as I'm aware with them. But I hope that we will have time to do live presentation as well after I'm finishing with these examples, because right now we can only see the picture and it's difficult to understand what is your user experience with it. But in general, even if you are not subscribed to any alarms, or you want just to have a whole picture of what is happening to WLCG network, you can just visit a homepage of PS Dash, and here we are depicting the sites and their status over past 48 hours. And here is also very convenient thing, the list with the sites which are prioritized, and you are getting first with the site with the not only the biggest amount of alarms, but also alarms which we consider to be the one which affect the network performance the most. And for example, while I was preparing this presentation, I guess it was somewhere Thursday or Wednesday, I've noticed that this US side was first in this list, and it reported 14 network alarms. And of course, I was interested what is happening there, and I wanted to see a bigger picture of alarms we are getting. Here, or maybe that's a proper time to go and visit the report. It will take a second to update the site. So here we can see the status bar. I hope that you also can see my tab, and I opened the PS Dash for you, not a presentation right now. Here we can see it's a bit different, looks a bit different than on the slide, because it's updated and it's this last week, not the previous week I taken, but we're still catching those events I wanted to show you. So on the top, we can see a status bar, and we can see that we identified the status to be warning for 4 days in a row. If we are opening this tab, we can also see which sites which alarms affected this, and that was ASN path anomaly. that affected the status of the site. What is also interesting for us here that maybe I need to tell a bit more about ESN path anomaly. ESN path anomaly means that while packet was traveling, like simply that while packet was traveling, we expected it to go through certain autonomous system numbers. But at some point we experienced that like new numbers, unusual for us, and the event, like when we are developing new alarms, we have some assumptions about how the network work, and we had an assumption that if sometimes this happens and we experience anomaly, potentially it can influence, for example, packet loss. And we wanted to catch this event, and this site actually shows this event to us. So we can see that here we experience during this day the biggest amount of ESN path anomalies. And simultaneously with that, we have an alarm that reports a high packet loss on multiple links. That was July 30th. So let's check this date and see all the alarms for this day. And especially those two of our interest. And if we are opening ESN path anomaly side, we will see the list of all the pairs where we experience those anomalies. Lots of this pair included sites from UK, as well as high packet loss here in the list. We can see that lots of sites there are also UK sites. So we can see the correlation between changes in this ESN path and high packet loss. Now, of course, we have more visualization for those ESN path. We can look this ESN, like autonomous system numbers and the anomalies they had. This is alarm developed by my supervisor, Petya. And I just grouped it together and visualized to kind of have to be like storytelling, a bit storytelling case. Then we can see whether, for example, this side was always a source on a source destination pairs. We can also see that this is here we can like see three groups of anomalies of this new autonomous system numbers. One group is for UK sites, another group is for Japan side, and this ESN happens on our way to Belgium. And let's return back to presentation. So that is one case we caught it that was quite interesting and something we hope to catch with our system. This I already showed you live. Oh yes, that's also like on the web page. You can click to all the alarms and to see the visualization to all the alarms and compare what you see. And for example, we can leave only UK sites we were interested in, and we can see that at the same time we experience ESN anomalies, we experience this increase in packet loss. There is also a similar case that is kind of again justifying our assumption about these alarms. We again have a quite big number of ESN path anomalies on this site in Netherlands, and we again experience high packet loss this day and in the next day. But the difference here is that we also started to experience firewall issue, despite the fact that previous 5 days it wasn't the case. And also I'd like to tell you about other potential cases we can experience, or we hope to catch one day, for example. One of them is partial high packet loss. So some days they do have high packet loss, others they don't. So there's kind of inconsistency in how we are getting the data, when it's complete or not. And we actually got this observation on this Brazil side, so we can see with the yellow mark the days when we got this alarms from multiple links. So this can suggest either congestion or insufficient capacity of the site. So one day the demand is higher and the capacity of the site is not enough to deal with all the requests. Another day everything is okay. And other cases we haven't caught yet, but we really hope to catch is bandwidth fluctuations. Sometimes then the infrastructure, something in the infrastructure was updated, we expect to see how it influenced the performance of the network. Of course, we would like it always to be the positive influence, but you never know. So we are tracking both the bandwidth decrease and bandwidth increase to catch like some interesting or maybe important events which are happening to the network. And one more case we also like to experience is to catch is a correlation between packet loss and throughput. So naturally, we expect that if we have a decrease in throughput, we are also expecting maybe to get some packet loss on this source destination pairs. Also, as a summer student, I had been working on host not found alarm. There was an alarm while I was visualizing and working with all the data from Elasticsearch. I noticed that sometimes we have some gaps in data we are getting, and of course we would like to know whether we are getting all the data we expect to, because that directly influence our results. As a summer fellow, I finished at the stage that I just implemented this alarm and we deployed it, but it didn't have visualization on PS Dash. And now we have visualization. And here, for example, you can see the given site in top right corner. We only are getting tests for latency for this given host during a long period of time. You can adjust the period of time and to see whether it's the case, like whether it's on a regular basis or it changes from time to time. And sometimes the host, we're getting the data about this host, sometimes we are not. So we are only getting this this data, and it shows us that we also need to take into account that sometimes we are not getting all the data. And also we have future work planned, something to do. So I finished the part from my project proposal with a site report. But we have two more things planned, and this is the development of new alarms. Lately, I started working on the first alarm mentioned here, OPN path disconnection alarm development. This in this alarm, we hope to catch disconnections among tier 1 sites. So in the top right corner, you can see expected picture of how we are expecting the data to be transferred from side to side in the tier one among tier one sites. But as I started working on this, alarm, I noted that, and we discussed it together with my supervisor, that this is the bottom plot. It shows all other data about PS trace routes, from all these given sites, and we expected all the sites to be interconnected because we would like to reach all the destinations from any source. But what we can see here is that sometimes we don't even have all the sites interconnected, and some of the connections are completely red. So on this slide, I'm showing how I interpret and why I marked some connections with red color, some with green, and some with yellow. So green connections mean that I chose the data throughout the week, and I hoped to catch at least one case. Then the packet reached the destination and went from one side to another side. And in this case, I expect the path to be complete and the destination to be reached. Another case is the yellow connections. Those are cases which I assume can be a firewall issue, as we have sometimes paths completed, but destination was never reached. That means that the packet went through all the hops we expected it to go, but it stopped like right before the site. So like how to resolve this issue is to change the configuration most probably is to change the configuration of the site and to remove this firewall issue. But the red sites are like a big question mark for me, as here not the path, not the destination have never like a status true. We never have complete paths, and we are never reaching the destination in this pairs of sites, and that is kind of unexpected behavior. So what I need to do on this stage is to ask someone with more expertise in a OPN about what are the reasons that this can happen. Unfortunately, the person I need to address right now is on vacation, so I hope to return to this next week and to make a progress on this. And if we progress with this alarm, we can find the disconnection between the paths, or potentially we can find some maybe issues with configurations and improve the picture we are getting right now. But while waiting for the person to return from vacations, I have another alarm to work with. It's overloaded persona toolkit. While doing my previous work as IRIS Summer Fellow, I noticed that some hosts are tested much more frequently than others. For example, this plot shows trace tests we are getting to Elasticsearch, and it's easy to see from this graph that some hosts are tested several thousands of times a day, while others are not tested at all or very few times, and as a result, some persona toolkits can experience can be overloaded. To alarm, we would also like to alarm users about this as well. But what should be done here, and it's quite difficult. We need to not difficult, but complicated and interesting to do, is to find a threshold, because different hosts will have different thresholds. As I've already mentioned, that some sites they are of a higher demand, there are others of a lower demand. So thresholds for different hosts, they are also different. And the question is how to identify those thresholds, and to develop a proper alarm. And that's it from my side. I would be very happy if you are asking any kind of questions. Also was worried about, so maybe in some moments it wasn't clear for you what I wanted to present with that or this alarm. So we can look through those alarm again. And yeah, I'll be happy to listen to your feedback, to your questions, and thank you. Oh yeah, Alexander.
Hi, yeah, thank you. This was a super interesting talk. I have a question, a bit naive. I'm not into networking. So when there's an alarm pointing out that there's some potential issue, is it oftentimes the case that the issue is somehow on our end, which means kind of with the facilities or with the networks that are under the control sort of within our field, or is it often also related to an external issue where some internet service provider has a problem that we can't do anything about? And in that case, is it easy to somehow correlate these things to some external alarms that might tell you, okay, there's a more generic issue happening that is really not our fault and we just have to wait? Or really this is something under our control, and now that we see it, we should be doing something about it? Is it often that the issue really is on our end to resolve, or how does this happen in practice?
I will try to give answer first on my own, but I also will expect that Petya, and I'm not sure whether Sean is here, because I cannot see the whole list. Oh yeah, Sean is also here. Maybe we'll answer your question as well. But as for now, not all the issues, like not all the, then you are getting alarm, you are not expected to go and solve the issue immediately. It's rather the potential like a potential cause, and like we're trying to localize the problem and to show like to point to it more precisely, because sometimes the issue can happen between the sites, and if there's any kind of, if it influenced someone work and someone submitted the ticket, hey, I have a problem with this and this, and like the admin of the site, for example, can report that everything is okay on our side. We are not sure what is happening, like, or we cannot help you with that, and this ticket is just stuck and no one can resolve it. But our goal is to be able to provide users with in the long run, to create really alarms that will point you, okay, so that is happening within those sites. So maybe maybe something with a, I don't know, hardware that happened, or the cable was damaged, like something, because it's really difficult to pinpoint those those things.
Yeah, just to maybe add a little bit, Yana's got it right. Alex, it's a great question. The overall goal is to give us understanding of whether a problem is in the network or at the ends. So ideally, the type of incident we're seeing, and ideally its location, as Yana was mentioning, gives us insight as to where we should go to get it fixed. And so the goal right now is to make people aware that there is an issue, to provide them with information and ammunition. The standard way to proceed on a network problem is to open a ticket with your local network provider, who will then follow up with the intervening networks as needed. But yeah, the overall goal is just to raise awareness. And as you noted, often it's not something the Insights can do, but sometimes it actually is, like firewall problems or issues where you're having loss really at the ends. And that's what we want to do, is give people enough information to know there's a problem and at least a start on a fix.
Okay, I see. Yeah, thanks a lot for the explanation for this very interesting topic.
Okay. Thank you, Yana. Any other questions for Yana before we move on to Maxim? No? All right, thank you. Maxim, you're up next.
Yep. So, hello. This presentation will be about the development of Coffea schemas. Presenting to you will be me, Maxim, and I would like to give a huge thanks to my mentors for supporting me throughout this whole project. So, to start with the presentation, first off, what is Coffea used for? Well, it is used for if you have a root file, for example, and you need to analyze it somehow. You can use Coffea to transform it first into awkward array and then do your analysis. Let me show you that quickly in code. So if you want to use Coffea, first we get this example root file, then we install Coffea. Here at the end we can see all the libraries we need for Coffea, and I'll mention this a bit later. Then we get this root file and call this from root function that transforms this root file into awkward array. Let me run it. Now, if you call events, we'll see that it's a Coffea method. And if you call this .events method, we'll get the awkward array itself here. And what we see here is an awkward array where each row is an event. So we have 40 rows or 40 events, and every column here is a parameter of this event. We can see in more detail. We can take the first event and see the first 30 parameters of this event. So here we see that each event has jets, electrons, information for them, and other parameters. Here we can call for all the jets across all of the events and see that this event has only one jet, these events have multiple jets, and we can call for the jet from the first event. We see that it has 5 jets, and we can even make one more step and get all the masses of these jets and have 5 masses. Now, after this brief example, let's see how Coffea works internally. Well, to first upload root files, it uses uproot, which converts them to the T-tree structure. And to convert to an awkward array, it actually uses something else, and internally we call it schemas, Coffea schemas. And these schemas depend on what root file type you have. So here are all the schemas for Coffea. There are nano root files with nano AD type format, Fizzlight, and others. In my example, we can see that our root file was nano AD in a nano AD format. And after this brief introduction of what a Coffea schema is, I want to get to the main topic of this presentation, and that would be how we plan to develop the schemas. And we actually decided to move all the schemas into a separate package, and we called it awkward zipper. Now let me show you in code in more detail how to use it. And on the fly, I also explain how awkward zipper differs from Coffea and why we actually decided to make a separate package. So for it, we should install awkward zipper, get the uproot that Coffea also uses to load root files. We need a specific version that supports virtual arrays, more on them later. And we also get the same test root file. Then we import uproot awkward. Then we load the root file using uproot. Coffea does the same, but internally. And then we call for .arrays function from uproot to get awkward arrays from this root file. And if we see this array, we see that it's kind of similar that we get from Coffea. However, if you look in more detail, like we have 40 events, every row is an event, but if we look at the parameters in more detail, you'll see that they are not grouped. So electron here, we have a separate field for every electron parameter. And that is actually the idea of Coffea and Zipper, that they group these parameters together for the same bigger parameter, so to say, for electrons, jets, and other parameters. So we've got this awkward, simple awkward array from uproot, and we can use awkward zipper now. We can call nano AD format. And this result that we get from zipper would be actually the same array that we got from Coffea. Now let's get in more detail. Oh, actually, I forgot when we installed awkward. Here we can see that it needs lots less function packages. Unlike Coffea, that's the first advantage of awkward zipper. Now let's get into how it works internally. So after we load the root file using uproot, we can add our own fields. So, for example, we have this local index branch with jet electrons indices, and we want to make global indices. Now, awkward zipper has these kernels, small little functions that create new fields. You can create your own kernels if you'd like to create your schema. I won't be getting into detail how these kernels or small functions work. I just wanted to point out that if we look on this function, you'll see that it works on awkward arrays. So the input for this function are awkward arrays, and it uses high-level awkward functions to operate on them. So fill, none, flatten, and so on. It can also use NumPy functions to modify these arrays. And this is a second difference between, and the main difference between awkward zipper and Coffea, that awkward zipper uses awkward arrays, and high-level functions to modify this arrays, while Coffea uses while Coffea breaks down these awkward arrays first on buffers and operates on them. This change will make it easier for users to create their own schemas in the future, or for us maintainers to maintain the existing ones. Now, after we created any new fields that we wanted, we should actually group them, which is the whole idea of Coffea. And there are a couple of a couple of cases here. The most simple one is where there's only one branch exists with some name, and when we group it, we have a single flat array. So here we'll have 40 run IDs for each event. Now that was the most simple case. A bit more complicated one is when there's a parameter with some name, and it has, for example, PS weight, and it has a couple of parameters. Now, the parameters for it are grouped into a single jagged array, and each event will have a flat array of this parameter. Now, a bit even more complicated case is, for example, with generator, is when each event has a generator, and generator itself has lots of parameters. So we create a record for a generator and group all the generators for all events. So we'll have 40 records of generators with each generator for an event. And the most complicated example is when we have a couple of record instances for each event. For example, jets. Each event has multiple jets, and each jet in itself has lots of parameters, and it is a record. So we group them like that. So after all these groupings, depending on the case, we group all these fields once again, and our final result would be our awkward array that we wanted and that we get from Coffea. Now, after this brief introduction how awkward zipper works internally, I wanted to show you how to use virtual arrays with zipper, which basically all the examples I showed you before were on materialized arrays, meaning that the values were loaded from disk into your memory, and you can see this because we have actual numbers for our data. And virtual arrays are basically not materialized arrays, so they are not loaded from disk. To use virtual arrays, we use uproot the same way. Then we call for a similar function called virtual arrays instead of arrays, and we also need an access log, which would keep track of what fields we materialize. If we run this and then put this into zipper, we can see that access log is empty, so no data was materialized. And if you see at the final result, we'll get the same structure as we are getting from Coffea, but here, instead of data, we'll have these question marks, which basically means that all of them are virtual arrays. Now, if we get only jets across all of the events, we'll see that not even the data of how many jets are there in each event is loaded. And if we'll take all the jets from the first event, we'll load this information of how many jets are there in the first event. And if you look at the access log now, we'll see that this branch called njet was materialized or accessed. And if you look at this branch, we'll see that it's just that. It's information about how many jets are there in each event. So 5 jets in first event, 8 jets in second event, and so on. Now, a simple example of how you would use Awkward Zipper for actual physics calculations. For example, for ZP calculation, first let me reload the array. So we have so no data is accessed here. Now we can count the combinations of muons. If we call for access log, we'll see that the information about how many muons in each event is loaded. Then if we count invariant mass and look at the access log, we'll see that the 4-vector coordinates were loaded for that, and those are muon, pt of the muon, phi, eta, mass, and charge. Now we can plot a histogram for that. Just a moment. And we'll see it plotted. Now, interesting part, if you look at all the muons, we'll see that the data is still not loaded, so those are virtual arrays. But if we look, for example, at this force event, which has muons, and we'll take the first muon, we'll see that all the parameters are not loaded, except for those that we needed for calculations. So pt, phi, eta, mass, and charge. Now, besides this example plot, I have a notebook with other histograms. If you're interested, here I install the same libraries. I've already installed them. I have this small helper functions to load data using Coffea, like we did before, and Zipper. Here we have this test root file. We load this data with Coffea, with Zipper, and now we can plot 2 histograms, one on top of each other, and we can see that they are identical. So it means that Zipper works the same for physics calculations as Coffea. And I have here the same histograms plotted side by side. You can also see here that they're identical. There are more histograms here. I won't be getting into detail here. If you're interested, you can look for yourself after the presentation. And speaking of, if you're interested, there's actually now a documentation page for Awkward Zipper. Here you can find small guides on how to quickly start using Awkward Zipper, and in more detail what new fields are created for Awkward Zipper and how they are grouped. And there are even here some Jupyter notebooks with examples, like the one I just showed you with histograms. You can check it out if you want later. So documentation already told you about it. Now to quickly recap what I was presenting today is first of all, the advantage of Awkward Zipper being a standalone package is that it's a smaller package and it would be easier to maintain and develop. It has fewer dependencies than Coffea because it only needs the ones for creating awkward arrays from root files. And also I've introduced some simplifications in how the schemas work internally, that they work on high-level awkward arrays instead of buffers. And it will make easier also to develop these schemas and to create new ones for users if they would want. So, sorry. And also a bit of a roadmap for this package. Right now, Awkward Zipper supports eager arrays, meaning materialized arrays, and virtual arrays, not materialized arrays. Both of these modes are well tested and documented with examples of how you can use Zipper and how it works internally. And with that, you're currently free to use awkward Zipper if you use nano AAD data. Also, in the future, we plan to migrate all the schemas from Coffee to Zipper and make Coffee use those instead of its internal schemas and get rid of them altogether. And finally, any new schemas that if someone would not want to create a new schema, it is very encouraged to be made directly on Zipper. That would be all from me. Thank you. Any questions?
A few questions. Matthew?
Hi, thanks for the nice talk and all the nice work. This is great to see. I think you might have slightly answered some of my questions in your final slide, but can you go back to your slide 9, I guess? Yeah, so, okay, so the plan here is to be able to replace Coffee schemas with awkward Zipper, but then is the idea for people who want to add new schemas that they just have them be their own standalone things that can then just be consumed by awkward Zipper or interact with awkward Zipper, or is the idea that people would still contribute schemas to awkward Zipper that would then get brought into Coffee through the awkward Zipper dependency?
Yeah, if you'd want to create a new schema, it would be better if you create one in awkward Zipper, and then Coffee would use awkward Zipper with this schema.
Okay, so new schemas could be contributed to awkward Zipper and just be brought in that way.
Yep.
And then you have the arrow of currently here at first release. So is awkward Zipper on PyPI now then?
No.
Okay,
But
but soon?
it's planned, yeah, soon.
Okay, fantastic. Thanks.
Thank you.
Hi, yeah, I have a few questions. I don't know if they get too technical, but I guess at the high level, what about schemas that are not in the Coffee repository? So, I mean, there's one that comes to mind now for Atlas, which is the one I'm kind of most exposed to now that Jordan is working on. How simple do you envision it to be to port from the way that these schemas work right now, which I guess is using Coffee internal functionality, over to this package?
You mean to keep this package separate?
No. So I believe the idea would be at some point Coffee uses the internal infrastructure
Schemas.
it uses for its own schemas, right?
Yeah.
So people right now who have external schemas would need to update those to work with awkward Zipper, right? Because their dependency disappears if that code gets removed from Coffee.
Yes, but I think what awkward Zipper outputs is identical to Coffee. So
Right,
it would be
but
pretty easy to.
Oh, so the functions and the interface stays the same, is what you're saying?
Mm-hmm.
Okay,
It
then
uses the same kernels and schemas, so to say, but not schemas anymore.
Just to add on this, I think there needs to be some migration change as soon as Coffee removes their schemas internally, because how things are created with this package here is now based on arrays, and internally in Coffee it was based on very nested dictionaries, and basically the metadata of an awkward array, the forms. So there needs to be some migration code, but my assumption would be that it's actually easier to develop with this now, because you can actually have a look at the numerical values and not blindly have to code basically how a form has to be transformed.
Okay, so in this case, I think it might be useful to get in touch with Jordan if you haven't been before about this. I mean, this is a use case I know of. I don't know how many other people may have external schemas, but one thing that is a bit special about this schema is that because of the way we do systematic variations in this workflow in Atlas, they already come pre-evaluated. So you already have in your file branches that correspond to variations. And the schema also packages up this kind of stuff to have like kind of a systematics interface. And I think that goes a bit beyond what the Coffea schemas have done so far. And I don't know to what extent this infrastructure will be a mess to port over to some different API. So I think that might be something that's good to talk to Jordan, especially if you say that it might be easier to go this route before he goes too far into the development, because he's kind of very actively working on this at the moment.
Yeah, that makes a lot of sense.
Okay, and I had another question, which I'm totally forgetting now that I was talking about this. So I think I will just write to you on Slack once I manage to remember. Thank you very much.
Thank you. Sure, you can write me.
Things in chat. Okay.
Ah, sorry, I remember. Yeah, can I ask one more? I wanted to understand. So for me, the way I think about a schema is that there's two pieces. One piece is attaching behaviors to groups of arrays and viewing them kind of as an object. And the other piece is just rearranging the data, kind of in the way that you demonstrated, where you group everything together and that it's a jet instead of like a lot of different vectors. Are you also touching the behavior part here, which then allows for things like calling .mass on an object and that getting calculated? Or is that not connected to this here?
Yeah, behaviors migrated from Coffea as they were there, and Awkward Zipper also has behaviors. The same as Coffea had.
Okay, so that part would also then migrate out of Coffea. So that's all in one go. Okay, thank you.
I even have a test that checks that all the behaviors are the same in Zipper and Coffea for some example root file.
Okay. Any other questions for Maxym? Thank you, Maxym, for the talk. Thank you to Yana as well. That's all we have for today. So thank you all for coming, and see you all again soon. Bye.
Thanks. Bye-bye.
Thank you.
Thanks.
Goodbye.
Bye.
Bye.